We'll start today, just introduce generally what's the current project, the previous projects, and what we are looking for in our project, what are the objectives and project objectives. They are like semi-industry research projects, and hopefully they will be helpful for your research and your stuff. Then let's just start from this, that I firstly modeled and studied the gas networks and fluid mechanics of the study of the fluids, and what are the difference like variables we have in the gas network and how they will impact on the gas network. For example, what are the main variables of the gas network, and how they will impact on each other. For example, we have pressure, flow rate, density, compressive factor, line pack, gas constants, and physical parameter of pipeline, and equipment that we are using in a gas system, gas network, how they impact each other. For example, if I increase the pressure, what will happen to the flow rate? If I decrease the flow rate, what will happen to the density and the pressure? These kind of things in the real world you will see, and I will show you and share presentation and slides that will help you to be familiar and with the concepts. So let's start with this pressure drop rig. We designed this pressure drop rig. We tried to make it colorful. First of all, whenever you see a pipe with with the yellow color, it means that we have gas there. We have natural gas. The symbolic color, let's call it symbolic color for natural gas, is yellow in code and standard. So this is designed for natural gas. But here the project is testing hydrogen blends. We want to blend hydrogen. This source of the hydrogen is the green sources. We call it green hydrogen with natural gas, with methane, mainly methane, to just see what will these blends impact on the operational variable. For example, on pressure drop, on flow rates, on density, current value, leak, and leakage. So, and they are the important objective of the project. We have mass flow controllers here. You can see different parts of the project I want to introduce you. We have mass flow controllers. I will show you from the closer frame to see what is the mass flow controller and the technical detail of the mass flow controller. Then we have a pipe, 10-meter pipe. A half inch is the size of the tubes, and the pipe is 1 inch size. And also we have two pressure sensors to measure the pressure in inlet and outlet of the pipe. And at the inlet we have gas connection that is connected to the hydrogen blends or natural gas, pure and plain gas. And in the outlet we have Bunsen burner, burn the gas to generate the flow rate in our system. Let me show you another interesting thing. In a laboratory, we have to follow the regulations and the safety regulations and safety scopes. One of the safety scopes is using vent system. We have an extractor arm here to vent the burn gas. Let me show you, just bear with me a second. Ta-da! Here it is. This is we call it extractor arm. You can see is venting the gas, venting the barren gas, the flue gases on top of the Bunsen burner. So we can move it different angles. There is a switch and we can switch it off. You can see, you can hear the venting, and also open to fully vent the gas. And when we are the barren gas, we put on top of the Bunsen burner, and so all emissions and the flue gas resulting from burning the gas will be vented using this extractor. So it's important. Also, another important thing in the lab you have to follow is just first of all you have to read the structure of every rig that you are going to use, and then generated actually a label for our gas bench, and everybody can read what are the criteria here threshold, and you have to follow what standards. For example, this technical specification of this rig, what safety items you have to follow, and this is important, very important. Safety is the first and primary important. So this is overall view of the work package, just this work package, and I will introduce you one by one what will happen here. We have